Hello my friends of Hatari Labs, welcome to this tutorial. This tutorial is of a tutorial for the elevation model conditioning and string network delimitation with Python and Pysheds. Okay, this is actually an updated version of another tutorial. Okay, so the another tutorial will be Hatari Lab. Give me a sec. Is this one? Okay. Is this one you will have on the description of the tutorial, and in this tutorial you have a tutorial as well about how to install Rasterio, GeoPandas, GDAL, and Pysheds. Okay, on the last version of Pysheds, it is possible to do more stuff with the DEM conditioning. Okay, so what is the DEM conditioning? The DEM conditioning is and then it comes a little bit of theory. Okay, so in order for the computer to understand how is the string network, okay, you need to have hydrological corrected DEM. Okay, what is hydrological corrected DEM? It's a DEM where water come from the top part. Actually the surface water that runoffs actually runs from a certain point to the discharge point. Okay, so you are here, so you need to that the water that is actually running is on surface runoff actually goes from a part of the watershed to the discharge point. I mean, remember, we have to go to the discharge point. Okay, but what will happen if your elevation model actually has a sink? So this is a sink. Water cannot go to the discharge point. So actually, imagine that the water is coming in this direction and it and this water will find this sink, and actually water will stop here. Or what happens that it has a peak? Well, if this has a peak, water could not run to the discharge point. Okay, so this is the so actually we need to fill those sinks. Okay, actually it's called, if you come from QAS or SagaGIS, it is stated that there is a tool that is called fill sinks, because actually it fills the sink, so it creates a new digital elevation model optimized for that the water come from this. I mean that the water could reach the discharge points. Okay, so this topic is actually very popular in QAS. It's very popular in another software, but we want to do it in Python, yeah, because we love Python. Okay, so how can we do it? Okay, so you will receive this folder. The folder has some raster files, and it has two raster files. This is a image that I actually downloaded from the gdex, from a USGS. Well, actually, I can show you which is the. So it's actually this server. Okay. So this server actually downloads digital elevation model, but this is uncorrected digital elevation model, so we need to download it. But since I wanted to show you a procedure that can works when you are working with, because the server provides you the digital elevation model on a geographical coordinate system, so it's WGS84. But if you want to use a UTM, okay, so if instead of working with geographical you want to use a UTM, I have reprojected this to WGS84 zone 13 north. Okay, so and then we are going to show you how we can do it with both rasters, because actually, I mean, you don't want a procedure that will work just for one raster or under a certain condition. You need a procedure that is trustable enough that you can work with many conditions, yeah, because actually you will work uh, on different countries or with different system of projection, so and so on. So you need a tool that is capable of doing many things. Okay, maybe not if you are a beginner, but if you are dealing with this stuff, it will be very complicated for it will be very complicated to do some pre-processing stuff in another software. So actually, we want to create all of this in Python. Okay, so let's start. I will start my Jupyter Notebook. Okay, so you have to do it to put it on your. You have to put this also the folder that will be provided in the description of the video. You have to put it on your documents. Yeah, I do the I do all my tutorials in Windows. It's not actually because I like Windows most, because I know that most of the hydrologists and hydrologists works on Windows. Okay, this process of installing the libraries actually are much quicker in Ubuntu or in Mac. Okay, but since I wanted to for I want to do the tutorials like for the most audience, I use Windows. Okay, so here we have the elevation, model conditioning, and string network delimitation with Python and Pysheds. Okay, and here we have some scripts. Then we are going to have there are two reference scripts, okay, for you. But now we are going to work. It will be tutorial 1 in WGS 84. So we are going to work on geographical coordinate, WGS. Great, so let's start. Okay, first of all, we are going to import the required libraries. Okay, that's it. Run. So this is import the required libraries. Import the required libraries. Okay, great. Now then we open our raster. Open our raster. Open a digital elevation model. Digital elevation model. So this digital elevation model, okay, comes as a TIFF format. Actually, the TIFF format has the system of reference inside, okay, and we are going to call it a DEM, digital elevation model. Yeah, great. Then we define a function to plot the digital elevation model. So, and then we create this. That is a function that actually will plot the digital elevation model. Oh, okay, great. And then, I don't know why, but in order that for the color scheme, we create, I do a slicing here. This is a slicing in NumPy, yeah. I do it because otherwise I do like the T file can have some on the borders some zero values or not a value, no n and n, so it's not a number value. So actually those cells are empty, and this creates that the color map, I mean the color scale will be kind of crappy. So that's why we do so it's a minor slicing on borders to prevent uh, to enhance color bar, to enhance color bars. Yeah, otherwise the color bar won't be otherwise the color bar um, won't won't appear, won't be pretty. Then we plot the figures. We plot the figure. Okay, and this is the figure. Okay, look, this is the digital elevation model. Pretty full. Then we detect depressions. Okay, so what is a depression? It's a sink. Okay, we detect depressions. Okay, detect depressions. Okay, so we come with the DEM and then we show the depressions. Okay, detect depressions, and these are all the depressions that are in this raster. Actually the figure size is not the same, but don't worry. Okay, so these are these are the rasters. Okay, and then after we detect the depressions, we we fill those depressions. Okay, we fill the depressions. Okay, okay, this one actually uh, is filling the depressions, and it comes with some this really depends on the numpy and etc and so on, because this is a stuff that is not something that is related to you, that is related of how the how this being programmed, the code. And then we show the depressions. Okay, but after, I mean, this is the flooded DEM. Yeah, after the filling the depression, actually you don't have nothing because there is no more depressions on your DEM. But okay, so you have under you have filled the depressions, but it doesn't mean that you don't have that your digital elevation model is on the right shape in order to do some in order to do the to define the string network, because you have filled the depression, but actually your DEM have some flat parts. Okay, look, those all of these parts are flat on the DEM, and if this is flat, actually water cannot run. Okay, so in order to create a string network, we have to detect the flats and we have to resolve the flats. So actually we have to create a depression according to the flow direction, according to the difference on elevation, that actually will provide a depression that will reach the discharge point. So that's why we have this, we resolve the flat, so we run it. Okay, and this is actually the same DEM. You won't find the difference because these are arrangements, but on the pixel, so it's actually it will looks the same for you. Okay, then we have our direction map. Okay, then we have the flow direction. uh, here we create a direction map and create a direction grid, create a flow direction grid, flow direction grid. Okay, so this is the flow dir. Okay, I just run the cells. I'm running the cells on my keyboard, that is shift plus return, but you can run this with this as well, don't worry. And then we show the flow direction. Okay, this is the flow direction, that's right. And okay, and then we define the pour point or the discharge point. We define the discharge point, and then we delineate our catchment, that is just this command. Okay, we clip the bounding box to the catchment. Okay, and then we create a view of the catchment. Okay, run. So what we have done, have we done something? Then you see, maybe you don't see. Yes, we have done something, because we have, when we plot our DEM view, that is actually what it will come from the catch, also the catchment, it will have the catchment. Look, it's already delimited, so it's a digital elevation model of the catchment. And then we export this digital elevation model as a clipped elevation in WGS84, because this is on geographical. WGS84. Okay. And then we have a grid accumulation. Yeah. Because this is the DEM, and then we are going to have the we want to define the string network, so this is the string network. Then we define the string network here. Okay, and then this will define the string network, but as a grid. Great, this is a string network as a grid, and this is the string network of the direction map, and these are the streams. I mean, if you go to the theory, you have the what is this parameter? Yeah, you have to define a threshold, otherwise, like in this case, we are going to have the threshold that say, okay, we want the cells that has a catchment about more than 200 cells. So this comes here. Okay, so if we run it, okay, this is actually a JSON, okay, and with this JSON, we create a function to save the JSON, and we save the JSON as a separate file. Okay, so the streams look already here in the output. You have the clipped versions of WGS, and you have a GeoJSON. Okay, then I have done something like I say some functions to plot the JSON on a Jupyter Notebook. Okay, and this is some functions because you want to see. I mean, we are going to see this in we are going to see the results in QGIS, but we can see those results as well in a Jupyter Notebook. So here is this is the basing delineation, and this is the string network. Okay, some people have asked if I know the code to export the basing. Actually, you need to, it's possible, but you need to work around with this shape. Yeah, you have to create a JSON. Yeah, a GeoJSON. Well, I haven't, to tell you the truth, I wasn't in the need to do that. Okay, but if I was going to need that, I create this GeoJSON, this code, and okay, problem solved. And then I can use the leaflet just to create and to see my the basing, the string network on with the background map. Okay, great. So just to finish the tutorial, I will I will open the, okay, sorry, my documents. These are the clipped elevations, and these are the streams. Look, are there? Okay, and this procedure I will show you and demonstrate that actually you can do this with UTM, because this notebook here actually works with UTM, because actually it opens the WGS 30. Okay, it do the same procedure, yeah, and when it saves this clipped elevations WGS 30 north, okay, I will run all the cells. You will, this notebook is as well on the folder attached to this video. Okay, look, it takes maybe 5 seconds. Actually I can measure the time, but okay. So, and has done all of this, but with a DEM that is actually on UTM, I mean in another projection. So here this is the clipped elevation, but this is in WGS 80. And wait, because I have to create, there is one more than, okay, sorry, actually okay, sorry, actually has created the streams in UTM, but I do not show, I don't know why. Oops, it seems that there is a problem. Okay, I have to, I mean it imports, but I have to sign that is here, because actually by default it assigns that is WGS 84. Okay, so these are in UTM, and these ones are in geographical. Okay, so the procedure is actually, it works with several projections and is more helpful for you. You have to identify which is your projection and so on. And I hope that this tutorial will be like an enhance of the work that you do with defining watersheds, or like of your normal workflow, or like if you want to fancy around about how many shapes or do some statistics and so on, or just for your fun. Okay, my name is Saul Montoya. We are from Hatari Labs. Hatari Labs, what is Hatari Labs? Hatari Labs is a blog, yeah, in water source, in water resource software with open source tools. Okay, so we have a lot of tutorials, we have some online courses, we have this YouTube channel and many other things, a Twitter account and a Facebook account, and then you want to follow us. If you want to follow us, please follow us, and then okay, and I hope that you find this tutorial very useful and fun, and hope to see you in coming tutorials. So see you around and have a great day. Bye.